No
All
audio.
right.
Is it right? Are you guys able to hear us?
Yeah, I can hear it. I can hear everybody.
Okay.
I just double checked on our thing. We
Okay.
should be
All
we
good.
should be good here. Yeah. Hey
All
there,
right.
everybody. Yeah, please let us know where you are joining us from, wherever you're joining us here on the wide world of Al Gore's internets. We had a little bit of snafu with the streaming this morning, but we are live. Hello to the 8 of you watching on YouTube already. We got a bunch of folks checking in. First thing here, hello Omaha, Nebraska. Hello India. Hello New Jersey. I love it when people are specific. Hello San Francisco, California, and Aguascalientes. Hello DC, but in Thailand currently. Hello Kenya. Hello India. Hello Uganda. Hello Kampala, Uganda. Hello Berlin. It is
All
a
right.
global community, and we love to see it.
It is
This will be a
indeed a
fun
global.
episode. We've
I'm
done one
still.
of these. Yeah,
I'm yet to see somebody actually put in their latitude and longitude.
I'm surprised. With this audience, I'm honestly kind of surprised. Yeah, I hear it. I feel you. Yeah, we're having still some issues with our streams here. I'm double checking. For some reason, LinkedIn is giving us troubles. I don't know if they've scaled down their infrastructure or what. Okay, no, we're good. All
Oh
right.
God.
Yeah,
No.
we're good.
Actually, the other format was better.
Yeah, no shit. Oh wow, yeah, this one's gonna be harder to read. 225.2048 degrees north, 55. Sorry, I can't do it. It's too long. It's just too many. It's too many of them. I can't
That
read them.
yes,
Oh wow, Carlos is exactly on the
on
Tropic
the
of
Tropic of
Cancer. If
Cancer.
we can find someone on the Tropic of Capricorn, we can, just fold up an Earth sandwich here. Yes, you're right. Satya did in fact ask for it. But yes, I think now's a good time to get started. You ready? You ready, boss?
Yeah, let's get started. Hello, everybody. Welcome to OpenCV Live. Today, we have a very special guest, Joseph Nelson from Roboflow. Roboflow is OpenCV Silver member for several years now. And not only do we do many of these webinars, they are also the most popular webinars on OpenCV. So today, we are going to discuss what is the future of computer vision and AI in 2025. And as always, Roboflow and OpenCV, we have very similar values, right? There is the amount of things Roboflow contributes to the community. I'm just shocked by it, and it's very popular. All the things that they do end up being very popular. So I'm very excited to invite Joseph yet again on the show. It's a pleasure always to talk to you. Hi, Joseph.
Thanks so much for having me. These are a blast.
All right, and also with us on the show is Phil Nelson. The two Nelsons are not related, I'm told. Uh, and Phil is the director of content and creative at OpenCV. If anything goes wrong with the show, including the streaming services, it's Phil's fault.
That's right. I'm taking responsibility for all of it. Unlike the
Right.
CEOs of certain other companies who shall remain nameless. Um, I am your co-host with the co-most, the second banana who's second to none. I'm also your plus one and only. It's Mr. Nelson if you're nasty, but you, my dear friends, can call me Phil here on OpenCV Live, and I'm here to remind you of a couple of things we do on every single episode of this show. The first of which is a giveaway to you in the audience. Stay tuned. Later on in the episode, we will be doing a trivia giveaway based on what we talked about here today, and the very first person to answer that question correctly will win the OpenCV course of their choosing. You can see what courses are on offer by going to opencv.org/university. I think I made Satya laugh so hard that he broke his camera, but he's back now.
I'm back.
Speaking of OpenCV University, there is a 25% off exclusive offer happening right now until I think, I'm not sure how many days are left in that, but go check that out on opencv.org. The other thing is we're taking questions from you in the audience. Please use the Zoom Q&A button at the bottom of the screen to ask your question at any time, or just post it in the chat system wherever you're watching. We're live here on Zoom, YouTube, Twitch, and LinkedIn Live, and we will do our best to answer those questions, as the late great Satoru Iwata would say, directly. So get those in anytime during the show, and we'll do our best to answer them. But before we get started properly with our predictions for 2025, let's talk a little bit about OpenCV and why it's important to support OpenCV. Satya, I'm going to go ahead and share the screen. You want to give the folks a quick little pitch?
Yes. Well, so OpenCV is, the biggest computer vision library in the world. We have about 2,500 different algorithms optimized for different platforms. But we need help. We need help from your companies, but we also need help from you individually. So if you're thinking about, donations, etc., the donate button is right there on the right-hand side. And there are several ways you can donate. We can, of course, you can ask your companies to help us, but also if you want to personally donate, we have several options. You can go and, to the donate page, which is opencv.org/support, and you can donate via PayPal, Stripe, or even, on GitHub.
Benevity.
We
Don't
have
forget Benevity.
Benevity, yes. Okay, that's another one. So for certain organizations, including Google and Intel, etc., if you donate and you tell your boss that you donated a certain amount to OpenCV, they will match. They will have a similar matching contribution from the organization to OpenCV. So that's really, really helpful for us. So please help us out. And also on GitHub, we have an option of,
Yes.
some people maybe
That's right.
already set up on GitHub. So we have made that option available also.
Speaking of which, Roboflow, one of our sponsors currently on GitHub, there's 9 of them. We'll say hi real quick. Mikhail, thank you. You Freesy, Roboflow, Jesus, our boy, DJ Greenwood, Nick Libertini, Blue Jay, Rotus Laboratories, and Victor. Thank you guys all so much for your support. You can also support us by buying a t-shirt. OpenCV has an official shop. We have a new shirt that we made up during the OpenCV team retreat. It just says import CV2. It's really all you need, folks, in the REPL there. So go get yourself like a hat or a shirt or some stickers or buttons or something. We've also got the classic OpenCV logo, and we've got the I Love OpenCV shirt in English, simplified Chinese, and in Espanol. There's also, coming up soon, Wednesday, January 29th, Ross and OpenCV are co-hosting a unofficial Photonics West meetup. Photonics West is a big conference that happens here at the Moscone Center in downtown San Francisco. We have a nice little bar restaurant about a block and a half away from Moscone that we're inviting the communities to come hang out and talk with us. Some of the folks from Intrinsic will be there, which also leads me to another thing, which is the perception challenge for bin picking. Can we spend 1 minute talking about this, Doc?
Yes. So we, usually every year we do a competition. This year it was delayed slightly, but, we were still able to announce it in January. We wanted to do it last year, but that's fine. So this is a very technical challenge we are doing in collaboration with Intrinsic and the BOP group. So bin picking is basically a robot arm. Imagine a robot arm which goes and picks different objects, and the objects could be arbitrary, right? It is not that, so it needs to plan how to go and approach this object. So it needs to know the pose of the object, how it is oriented in space before it can go and pick it up. So that is the challenge. And there are a lot of prizes, $60,000 in prizes, and your code will actually run on a real industrial robotic arm. You don't have to do it. We will do it for you, or Intrinsic will do it for you. But this that will be the final competition. Your code will go and run on this robotic arm and pick up stuff, right? So
Yes.
it is more technical than our usual OpenCV challenges. But if you are interested in robotics and computer vision, this is one of the top, things you can do for your career as well as for visibility. Because when if you become part of this competition, you're in the top 10, you will be invited to present your solution at CVPR, at a CVPR workshop. And CVPR is the biggest computer vision, conference in the world. It's very prestigious. If you make it to, CVPR workshop for this, it's it's like, you can show that on your resume and people will hire you. Any
Yeah.
robotics company should hire
You know,
you.
the vast majority of people in this industry will never present at a CVPR workshop. It's
Yeah.
a pretty big deal. Yeah.
Yeah.
So
All
yes,
right.
join the bin perception challenge for bin picking. That's bpc.opencv.org. Registration is open right now. The actual submissions open in February. $60,000 in prizes. Go get you some of that. I think now we can talk about what we actually came here to talk about, which is the future. I think it's the great old Criswell line, which you know, I think we're all interested in the future because that is where you and I will spend the rest of our lives. Yes.
That's an amazing quote.
Yes. The late great Criswell. He was a fantastic prognosticator on early television, like the old Tonight Show and stuff like that. They would bring him on there to make incredible predictions about the future. I'm pulling up our slides right now, folks. Give me one sec here. Okay,
There's one other workshop at CVPR that this audience may take interest in that
tell us about it.
we're aware of. Yeah. Um, so at Roboflow, we're doing another workshop this year at CVPR. Prior workshops have stemmed on, if you recall, we did something called object detection in the wild in partnership with Microsoft, which is a challenge to see how well given models and techniques can adapt to real world computer vision problems, particularly with an object detection task. Well, the scope of what models are able to do has expanded, and increasingly there's a new family of models, vision language models, VLMs, and there's quite a bit of interest of knowing how good or maybe poor performing is a VLM on given tasks and objectives. And this is actually a pretty open question for the community. For example, when Polygemma 2 came out, there was open question of how much better than Florence 2 was it? Is it uniformly
Hmm.
better across all tasks, or is there some places where you may want to continue to lean into other architecture types? What are areas that it's particularly performant in terms of speed or accuracy or vision question answering or grounding tasks? And these remain to be actually fairly open-ended questions for the community. We're hosting a workshop, or I should say, maybe participating in a workshop alongside some of our friends at Carnegie Mellon University and other institutions to encourage easier benchmarking of vision language models. Many may be aware that Roboflow publishes a benchmark called RF100, which is a basket of data sets from Roboflow Universe. So when folks build open source with Roboflow, they have the opportunity to be included in a benchmark that measures how well models adapt to real world tasks. RF100 has been adapted by labs like Baidu, Apple, Microsoft Research, and others, and we're extending it to do more types of tasks for VLMs. And so at CVPR 25, we'll have benchmarks of both self-driving data sets, but also of RF100 and some newer task types, which will make it be slightly easier for the community to answer the question, how good is this model on the task that I'm trying to solve? So in advance of the workshop, there will be a launch of the contest, likely March 1. And the launch of that contest will solicit requests for those to successfully complete the proposals. And as we work through with our partners of what that workshop fully entails, including making it easy to have access to compute to run benchmarks, making it easy for folks to claim bragging rights for the best techniques for given domain types. And it builds on the momentum of a similar set of workshops that took place at NeurIPS, one of the other prestigious annual machine learning conferences that just took place in Vancouver in December. And so there was strong participation from that workshop, and therefore there seems to be interest and intrigue of validating the success of VLMs, especially in novel tasks like aerial or underwater, or maybe document processing or digital worlds, medical or environmental. All these are domains where vision is going to have a massive impact, and ensuring that the community is building models that anchor to improving capability within those domains is essential to moving the whole field forward. So we'll certainly be sharing more details about that as the workshop and call for participation opens up. But as Satya and Phil mentioned, it's kind of like an easy way to be a part of a broader community of folks that are evaluating how models perform. And who knows, you could outdo a lot of big name labs with your own technique, almost like Kaggle competition style of an individual taking on the giants and winning. So looking forward to continuing to share details about that and hopefully seeing many folks at CVPR this year.
All right.
Absolutely, absolutely. Yeah, so I'll go ahead and share my screen here and we can get a rolling. We also have a special unannounced guest who will be helping us with these predictions, Gudetama, the lazy egg of Sanrio fame, unofficially joining us here. I should have put like a mustache on him or something. Let's go ahead and get started. Firefox. Okay, so I wanted to remind folks, the first one of these we did was way back in 2022, episode 41 of OpenCV Live, if you can believe that. Ain't that something? So let's get started here. My screen share still working? Did we lose it?
Yeah.
Okay.
No, it's working.
Cool. All right. So yeah, it's just a quick reminder. We're doing that thing with Ross. Go ahead and scan that QR code and join us. As spots are limited. If you are here local in the Bay Area, you know, Oakland or Mill Valley or whatever, you know, come hang out with us. It'll be fun. I think we're limiting it to maybe like 50 or so people. So, you know, register, come hang out. It'll be a good time. Karthik from Intrinsic will be there. Kat Scott from Ross will be there. I'll be there. You know, drinks, frivolity, things of that nature. Yeah, computer vision and AI predictions. This is also the third year in a row we have used this template. Yes,
Yep.
this template. You already know who we are. I'm going to go ahead and skip here. We already talked about OpenCV. It's important. You all know and love it. OpenCV.org. Roboflow. I think, you know, Joseph, you want to give us a 30-second. You talked a bit, but let's get a little bit more.
Yeah, the slide here actually can be updated. Over 1 million developers
Definitely.
with Roboflow.
Oh, wow.
That's how long. That's how long we've been doing this.
Yeah. So at Roboflow, I mean, we say our North Star is to make the world programmable. We want to give developers, companies in the community tools and platform and solutions to create the ability to deploy production computer vision. That entails everything from curating and creating high quality data sets. So we're invested in the ease with which you can prepare, curate, automate the labeling and identification of which frames matter most from video, or curating and collecting of the right amount of data, training and fine-tuning of foundation models or task-specific models, CNNs, transformer-based models, and deploying of those models. Increasingly, we're seeing folks that will train a model and then they'll be like, we like to say inference, now what? It's like, okay, cool. My model told me that there's 3 people on this Zoom, but what I really wanted to know was how many did I expect, or how long, or who spoke the most? And that requires kind of post-processing of predictions, or even using models together, which could be like tying together GPT-4 and VLM like Florence 2 alongside maybe an object detection model. And so we've released our open source inference engine, and then on top of that, a workflows product that makes it easy to stitch together all of that stuff. And we've seen pretty strong excitement and adoption of some of that tooling. By the numbers, so yeah, over 1 million developers have downloaded and used our open source in the last 30 days alone. The Roboflow community, thanks to a lot of the folks that are on this session. So when you build with Roboflow, we're deep believers in open source, not only in the tools that we build and maintain, but also making it free and easy to get started with building our platform. We've actually provided over 1 million hours of compute to the research community, GPU time to date and counting. And that's
Wow.
what's powered the
Hokey smokes.
increases of models, like over 150,000 published open source models across Roboflow universe that folks can take, use, fine tune, adapt for your own task, and over 400 million user labeled and shared open source data sets. That's what fuels the entire computer vision community to move forward. And so we build tools and platform with and for the community, the sorts of things we wish we had as well when we build and create things. And that is having this awesome reinforcing feedback loop where together it allows everyone to benefit from kind of starting at the end, or starting at the latest state of the art, or being able to put things into production more quickly. And so when you build with Roboflow, you actually move computer vision as a field forward. And we're elated to be a part of such a vibrant community of engineers, developers, computer vision, and companies, startups, and enterprises doing that. Over 25,000 organizations now build with Roboflow, including over half the Fortune 100. So we've been elated that a lot of the work of developers makes its way all the way to commercial impact. And of course, that allows us to fuel and invest further in our mission. So that's us at a super high level. Today, we'll talk more about some of the work that we're thinking about because, while we're talking about the future today, as folks, or as famously as said, the best way to predict the future is to create it. So maybe you'll have some previews of some of the things that we're excited about into 2025. So that's Roboflow and jazzed to be a part of OpenCV's ecosystem and more broadly, everyone that creates and builds with computer vision.
Well said, well said. And we do appreciate Roboflow, who, y'all put your money where your mouth is, and that's what I like about you.
Right.
In the distant past of 2023, we did one of these. Go check it out. There's the link right there. This is the second one of those we did. We're not going to watch it here, but we're going to quickly go over our 2024 predictions here at the top of the show. In the more recent, okay, I don't know what happened with that one. In 2024, I'll drop the link in the chat here. 2024 predictions review. Do you want to take the one off the top, Joseph, and talk a little bit about it, and we'll kind of alternate?
I actually think that one was Satya. So Satya can talk.
Yeah, go ahead. Go ahead, boss.
Yeah, so Gaussian splats, they made huge progress in that field. Actually, first of all, the computation that was required, it started with nerves, right? Nerves were these neural networks that could encode a scene. So the 3D structure of the scene, you could encode in a neural network so that you could reproduce. Let's say you have a scene, you take a bunch of pictures of the scene from different angles. Now you can recreate the scene from a different angle, which was not in the training set. And here it's one of the few applications of neural networks where you want to actually overfit the data, right? Because you're encoding, interview question. It's one of those very few
Definitely.
applications. Now, nerves were great, but they were also very expensive, right? They were not very fast to train. But then came Gaussian splats, and they are having a huge impact on how we think about 3D reconstruction as well as storing 3D data, right? And huge progress has been made in 2024. There are many libraries that have come out. You should check out things like if you do a Gaussian splat, just the search on Google, you'll see many libraries. Some of these libraries do Gaussian splat exactly like visualization of it, but they will. Some of them are also used for camera localization. So let's say you have a room. You basically take a bunch of pictures of that room and you create a Gaussian splat, but then you can also take another picture and it will tell you where the picture was taken from, right? Which is a very important part in robotics and security applications. I'll stop at that. So a Google search will give you several of these libraries that are, very impressive. Master, Duster,
Yeah.
Master, Duster, and there is Ace Zero.
I
and
don't
so
know
on.
that one. I don't know
Yeah.
that one. Ace Zero? I'll have
Yeah.
to look it up.
One thing that I think we've seen that this is prescient around is the foundation world models that have increasingly been trained and released. So there's more and more interest in modeling the physics of the real world and including both a sense of depth, but also perception. And it's this kind of class of foundation model that folks are calling world models that can simulate and both generate and understand, as perhaps the name implies, things are out in the real physical world. One of the most recent releases in this vein was NVIDIA's Cosmos model that maybe you saw at CES this year, which is quite impressive in its generative capabilities. For example, I've seen some demos where you can say, hey, like a self-driving car or just a car driving on a river, and then it'll produce 6 frames of like what the viewpoints are of a self-driving car from like the front, the side, and the rear. And all of those frames will be consistent, as in as like the car is driving forward,
Right.
all the frames will have continuity of context of what's seen, even adherence to a principle like driving on a river, which is
Right.
pretty, it doesn't respect the physics perhaps of a car on the river, but it does respect the knowledge of if you're driving, you see one perspective make its way to a second perspective, make its way to a third perspective. And so I think there's really impressive progress, a lot of that which is powered by nerfs under the hood for going from a 2D representation to a 3D representation of the scene. So I think that the splat to hologram pipeline was almost like an intermediary for this broader thing, which was world foundation models. So this seems like, in fact, the field, maybe as usual, outpaces even the most notable of predictions.
Right.
That,
And
that happens these days.
right. Um, Yeah, so one other thing which is kind of similar, not exactly the same, is this idea of taking 2D pictures and creating 3D out of it. And Apple has just nailed it, right? So especially if you look at these things using Apple Vision Pro, it's just magical, right? I actually took a picture of my mom. She's passed away a few years back, and I took a picture of my mom and made it 3D, right? And it was just surreal to watch it in Apple Vision Pro, where I could almost see her, right? Of course, there is no talking or anything like that, but
Yet.
it yet, right?
Again,
But
I've
the
seen
photo,
everybody out there needs to go fire up the Laserdisc player and pull out the movie Strange Days. Just go watch it. It almost destroyed Catherine Bigelow's career, but it holds up really well.
right? So yeah, so those technologies, and I think Apple's depth one is called Apple Depth Pro. That is the paper,
I believe
which
so, yes.
yeah, Depth Pro is the paper that actually go read up on that paper if you want to learn about monocular depth estimation. It's amazing. The results are just stunning.
All right, let's move on, shall we? Generative models for CV. How did we do on this one, folks? Like, I think it was a bit of a push.
I think
I
the
think it was
biggest,
huge.
yeah, no,
All right.
I think video generation models made huge leaps forwards.
Exactly.
Like for example, Sora 2 from OpenAI for generating scenes. Runway had a number of releases of their generative models. Pika Labs also released a number of models for prompt to video scenes. Um, so I think that if the prediction is that diffusion continues to show promises around, in this context, like video generation and frame construction, that trend seems to have not hit any upper bound on scaling laws or its potential. And I think that that will continue. Like, I think that I mean, even with some of the releases of current models, some of their biggest limitations is like a sense of object rigidity. Like, you'll see that some of the generations, like things will kind of like morph and change shape, or you'll see like things not respect the laws of physics, where maybe things will kind of like float in various directions when you prompt. Though I think that what's been suggested by a lot of research is just frankly more examples in brute force should get us to where rigidity and laws of physics will be increasingly respected. So I think that generative models doing a good work of creating, in this case, video generations of real world scenes, both in 24 continue to make strong progress without a huge sign of slowing down. And we probably should anticipate the same going forward into 25.
Right. One of the things I've noticed with these videos is that they are doing exceptionally well when to keep things in it's when you're simulating a camera motion, they are doing a very good job of that kind of keeping things consistent. What it fails right now is on places like, show me a gymnast doing something on the on the floor, right? And then the physics is violated. Like it's really
I've seen some
uh,
fun ones. Yeah, very, very
yeah.
like good old fashioned nightmare fuel, you know?
Yeah, yeah. But if you're looking at nature scenes and things like stock footage, so I don't know what it can be very dangerous for the stock footage industry because obviously these models have been trained on a lot of stock footage and paid for. A lot of times these things have been paid for. The stock footage companies have been paid for this data, but I think their business is gone, right? Once you train it on this data, even if they are paying licensing fee, right, there is an upper bound to how big these companies can be now, right? Let's say Google pays $3 million. That was the rumor a few years back to Shutterstock, I think. Um,
Probably something like that. Yeah.
yeah, but there are only like 10 Googles in the world, right? So they will all, okay, so the company makes $30 million. That's it, right? The, your,
Yeah,
your,
one thing that's interesting about that though is I think uh, people forget sometimes in the data sciences that real life is not static. Um,
right,
people are going to be wearing different clothes and like have different haircuts and like, stuff is going to be designed differently in real life in public, and you're still going to need that stuff like to some degree.
right,
And so, yes, I mean, I think it's already been kind of catastrophic for like the stock footage industry, as it were, but that shit was already kind of cheap already. Like, I mean, I have an Envato Elements subscription that cost me like $49 a year for
right,
infinite stock footage. So it's not like there were not a ton of jobs there, but
right.
I think you're right in that the bottom is gonna go down and the top is gonna go down with the bottom a bit in that whole gimmick. But we still are going to need photos and videos of real life to do things with, you know what I'm saying?
Right.
So
The
yeah.
funny thing is that I actually used the caption. So I went to one of these stock footage sites, used the caption that they use to create a video,
Hmm.
and it's not the same, but it looks awfully similar, right? Like the person would be, let's say, wearing a coat of the same color, a tie, a similar color. It was just,
It's
yeah,
almost as if that that the AI models couldn't exist without this stuff. I don't know.
right.
But let's move on. Let's move on.
Yeah.
Practically speaking, we've got industrial applications of AI-enabled CV. I feel like it was a pretty damn big year for that. Thoughts, fellas?
It was massive. I mean, and this is sort of a layup of a prediction. It's basically like saying like visual understanding tasks generally will continue to be
Line
prolific.
go up. Yeah.
Yeah, yeah. And I mean, maybe maybe some interesting nuance of what it means to be into practical and industry. I think what we'll increasingly see is models that are well adapted to individual domain types. So for example, like if you want really rich understanding of a narrow portion of a domain, we'll see more of that. So I mean, as opposed to saying, hey, like I have like you maybe a good way to apply this is thinking about like segment anything versus segment anything targeted at cell specific models. Like you saw SAM cell, like segment anything applied to cell
Right.
in microbiology. Like that's sort of a trend and sign of things to come. And the reasons for that are twofold, right? One is that like if you have more domain specific knowledge of a given task, then presumably you can do that task with more accuracy. And two, if you can distill down the portions of pre-training to a given domain type, you can also typically use small number of parameters, which means having a faster model. So, if think about the things that will never change. People will want more accuracy and people will want more speed. And if a way to get that is, okay, I just do domain adaptation, even of maybe a large model or a distilled down version of that model, that's interesting. And so that's kind of what it means, I think, to bring things into industry, like into industry contexts, is you have domain representation and targeted at what the given task at hand is asking to be done. So maybe that's a trend that I think will only continue to accelerate.
The benefit of talking to smart people like yourself, Joseph, is that you throw in a few nuggets, which are, one of the things that you just mentioned, it caught my attention was think about the things that don't change. And that's in business, in your academic life or your career. that's a very important thing, right? People say that AI is changing so fast. What should I focus on, right? Think about the things that don't change, right? And then you can. So this was an aside. It just caught my attention when you use that phrase.
Yeah.
Um, so yeah, I agree. I mean, I we can actually cut it short. You've pretty much covered everything. It has been a massive year for industrial applications of AI. So not much to say there. It's every industry, right? It is being transformed in a very big way.
Absolutely. Yes, and coming up next, I think this one will be a lot more fun. Number 4, breathless press hype cycles. We saw quite a few of these. In fact, right after last year's episode with our predictions, where we said this, was the uh, what was it? What was it called? Willy's Chocolate Experience. Remember that? The the AI generated, deeply upsetting ersatz Willy Wonka, Charlie and the Chocolate Factory experience they did out there, that became sort of viral in the early part of 2024. That one was kind of fun. There was also that AI generated Halloween parade in Dublin that didn't exist. Like they made up the flyers and stuff, and it was not real. And of course, there were some really big. I mean, I think the biggest ones probably were like the two big AI kind of pin, dedicated devices, right? There was the Rabbit R1, of course, which was, I mean, maybe so far the biggest AI flop. Am I right? Like, what else would be bigger than the Rabbit at this
Well,
point in terms of?
there was Rabbit, and then there was
There
this
was
hand
Humane.
thing,
There was
Humane.
Humane.
Yeah.
Yeah, yeah. That one, I think, at least looked kind of cool. Like
Yes.
they at least were copping, I mean, actually the Rabbit looked pretty cool as well. Teenage Engineering designed it. They do good work. They designed, among other things, the Playdate handheld console, which I'm a big fan of. It's got a hand crank on it, folks.
Huh.
Um, but yeah, I think the year in hype cycles was pretty brutal. Like I think they were shorter. The hype cycles were shorter, and like Marquez Brownlee, for example, was a big part of sort of severing some of the hype cycles of some of these guys just by being honest, and
Yeah.
he got a lot of hate for it. But yeah, any
So
other thoughts on some of the interesting like flops or failures or just
I,
thoughts about the way the press handled this stuff?
I'll tell you my biggest flop, right? So I did not fall for the Humane or the Rabbit. I did not buy any of those things. But I did fall for one thing, which has been a massive, massive disappointment for me. And that is Apple Intelligence. It does not exist, right?
Yeah, it's
It
not
was,
so good.
yeah, I have upgraded to, iPhone 16 Pro Max, and I'm still waiting for the magic to happen. Nothing is there.
I honestly kind of wonder if they're just not like Apple is kind of stubborn about this stuff, and it's pretty obvious to me they see this institutionally, this kind of stuff, similar to remember the old Steve Jobs quote about Dropbox, which it's a feature, not a product. And I think they see that about this, and I feel like Apple has been kind of forced, like against their will, to integrate some of this stuff at the OS level.
Yeah.
Like you see it with things that would just never fly in Apple products, like the incorrect news summaries that people are posting all of the time about like certain people being like fired or dying when nothing of the sort happened, but it says it right there on your phone notification. The very small things are nice. Like, a couple of years ago, just being able to copy text out of images, huge, right?
Yeah.
Absolutely huge.
Right.
Super game-changing tech, but it's a feature, not a product. And I think them having to bundle it all up into like Apple Intelligence is a very un-Apple thing to do. And it seems like they really didn't want to do it. And so they're just like kind of, it's like making a kid eat their vegetables, like they're just kind of like grimacing the entire time they're doing it. Thoughts from the two of yous?
I have maybe a more controversial take. I might be pro flop. I might be pro flop. It means someone's swinging for the fences. They're trying to do something new. They're trying to do something different, and they're trying to rally people around it. Now, of course, there's a difference between a flop and something that is never intended, like a scam, so to speak. But someone like swinging big, like if Humane Pin worked out, like, and there was a new computer interface, like that was a bunch of ex-Apple people that went on their way and said, "Hey, we think
Yeah.
we see a better vision of the future, and we think that we can build that better vision for end users." And then actually, like, I think what maybe tripped up Humane most was they were building their hardware interface and their software just before you had VLMs be ready to run on the edge. And if you build like Humane now with like that capability, you would probably make a lot of different assumptions. But I don't know, like the idea of like trying to get us a new computing interface of like a projector thing, it's like kind of maybe gimmicky, but that's also what we said when the first like touch phone only or touch screen only phones came out.
Right.
There's no way I want my BlackBerry keyboard, and now you're like hard pressed to find that. So
Which, I mean, in
I
fairness, it was true at the time. Those screens did suck. Like they were not good, right?
yeah.
Like until basically until the iPhone, they were not really usable every day. The
Right.
all, the first kind of all touchscreen phones. And so maybe that, their reach exceeded their grasp, as they say, right? Like
Right.
maybe, give it another year and there'll be basically a good version of the Humane pin. Like
Yeah.
who knows? And I like the way you said that. There's one of the greatest power hitters of all time, Mickey Mantle. They asked him, "Were you trying to hit a home run every time you went up to bat?" And he said, "Every time." And
Right.
it's true, man. You
Right.
watch him swing. He wasn't lying.
Right.
Let's move on here. Regulations. The
One
regulations.
other
Oh, yeah. Go
one
ahead.
other product. I actually want to that's a very good point that Joseph made, that we stumble through all these flops, right? But ambition does, the ambitious projects are the ones that finally give us new insights, and we move forward even if they are flops. And my favorite product in that category is the Apple Vision Pro. Complete flop, I know, but I love it, right? I don't use it every day, right? Whenever I use it, the experience is magical, right? It is just magical, right? So it's that is what I want Apple to do, right? Okay, they make things expensive, which is fine, right? But at least when you produce something good. And that is why Apple Intelligence is such a big disappointment. This is actually maybe the first Apple product I've bought and completely disappointed in, right? That did not live up to the expectation. On the other hand, Apple Vision Pro, it it is expensive, but it blew me away completely, right? Because as a computer vision device, I had underestimated what Apple engineers could have pulled out. This requires a lot of engineering and a lot of algorithmic development that happened. Sorry,
Yeah, it's
let's
the
go.
kind of stuff that damn near only Apple could do, right? I
Yeah.
think I think that's fair to say. Let's move on here because we're spending a lot of time in the past, fellas. Regulations. This basically happened. I mean, who wants to talk like maybe 1 minute about regulations, and we can move on to 2025?
Um, I think Europe is going to have a very troubled time adapting to the AI world. And if you're not careful in the US, the same thing is going to happen in the US also. Regulations are coming, and there are several attempts, right, at regulating AI, not the application. Applications should be regulated, right? Once you have self-driving, yes, it needs to pass whatever regulations we come up with. But the technology itself, right, I feel that it is too early to regulate at all, right? Um, Joseph?
The other type regulation that actually just took place on Monday in the US was an executive order
Exactly.
on the availability of compute broadly and some implications of running models on the cloud. And what you're seeing is a recognition of maybe the strategic national priority of AI. And so, while that's good on one hand, it means that it's in the national limelight and it's recognized as something where you want to invest in creating new chips, you want to invest in STEM education, you want to invest in the capabilities for people to build and create leading edge capabilities. It also comes with a sense of what is framed as responsibility, and I think sometimes teeters into the edge of slowing down really important progress. And so I think that you're going to see more of this, like so-called the rise of sovereign AI, where like, the internet itself, for example, fractured into various viewpoints across geographies and countries wanting to have different ways of representing to their nation what's available on the web. Sovereign AI is kind of a similar concept where, models are trained and can share information freely and openly. And also there's different capabilities that one can bring to bear. And so countries, a natural extension of regulatory effort is the ability to control and create advantage. And so I think like if I were to call like maybe a trend that is a close cousin of this, it's the continued rise of sovereign AI. So that means countries stockpiling their own GPUs. It means countries wanting to train their own version of what we mentioned earlier of like maybe you could have a segment anything or a GPT that's general. Well, what if I had a SAM or a GPT that's specific to my country? And things like this will, I think, continue to be on the rise.
Right. Right.
Yeah. All right. Let's continue, shall we?
Yeah.
So, folks, please post your questions and thoughts and ideas for 2025 predictions in the chat. I will be using our unofficial extra guest, Gudetama, here because Gudetama is also a magic 8-ball. We will be shaking the 8-ball to see what Gudetama thinks about each of these 2025 predictions. First, I'd like to highlight in the chat our good friend Mr. OK here says, the biggest problem with the marketing for so much of the AI products like Rabbit is that their marketing pitches seem like they were written by an AI trained on nothing but like QVC or Home Shopping Network late night infomercial pitches. They're copying just the worst of pitching copy and sending it out there as a message for their product. Absolutely right, Stephen. Absolutely right. Thanks for the comment. Yes, Carlos in the chat also says it's always better to underpromise and overdeliver. You could not agree more. So yes, let's. You have slides for a few. You want to screen share, Joseph? You can take over the screen share if you want.
We can introduce these, and then I'll jump in at the right moment when it will be relevant.
Sounds great. Let's talk. So, yeah, we put these together in advance of the show here. This first one was one I put in there. This one just seems like an easy bunt. Data center build-a-thon. We're already seeing this, where a bunch of states are sort of begging for these huge ecologically disastrous data centers to be built in various wildlife refuges and whatnot. Even as Los Angeles continues to smolder. Thoughts on data centers and what do y'all think will happen? Like, how do you think this is going to shake out? Do you think that we're gonna end up with like Utah's the data center capital of the U.S., or is it going to be more of a sort of these things are necessarily going to have to be spread out just because of the realities of climate change? It's not going to be feasible to have them centralized because if some shit goes down, which it will, you're greatly hamstrung. Thoughts?
The status quo for this is probably indicative of where build-a-thon will continue. So for example, like when you're building a data center, you want access to cheap power and water for cooling, and you generally want to be close to co-located to your users to reduce latency. So today, like the majority of data centers are in Virginia in the US. Herndon, Virginia is where a lot of the AWS US East runs, for example. A lot of data centers are in Des Moines, Iowa. In fact, GPT-4 was trained in West Des Moines, Iowa. And I like to joke that I went to high school with GPT-4 as a result because it would have been the same high
One
school.
more thing to blame Iowa for.
That's right. That's right. That's the right take. And I think you'll continue to see in the western regions across. I think some are in Oregon, some are certainly dotted across California. But you'll see likely the same sorts of trends for where current builds are taking place. So low cost of power, access to water, capabilities. But I think, as you said, it's a bunt. There's trillions of investment globally that's going to happen in AI generally, and already billions allocated, like earmarked, to the current year for the build out that Microsoft alone is planning to make over the next 5 years. So those are massive, massive figures when you put it in the context. And the fact that you already have a line item of, I forget the exact figure, but I think it was double-digit billions that Microsoft is investing alone in building and creating data centers to bring them online.
Right. Yeah, I think it was
Definitely.
85 billion that Satya Nadella said. Actually, as a general rule, there's a YouTube video where they explain why, let's say you want to look for some jewelry, you will find that in most historic cities, etc., you'll find that they are they're located together in a line. You would find that all jewelry people are in one area, which looks very
It'd be like the Diamond District or whatever. Yeah, yeah.
yeah, the whatever district. And you would say that, oh, why is that? I mean, are these people dumb? Why don't they actually spread out so that there is no competition, right? They are sitting right next to their competition. And the video actually explains very well how the game theory aspect of it, how even if they start out very far away, they will ultimately making best choices for themselves, they will end up in the same place. And the
It's
same thing
sort of
happens.
like how over a long enough timeline, everything becomes a crab.
What is that? I don't know what that means.
It's a famous evolutionary thing that the carcination, I think they call it, or whatever. Like, yeah,
Interesting.
it's amusing. Yeah, check it out.
Okay.
Here in San Francisco, we have a similar problem, not with the jewelers, but with over on 4th Street,
Yeah.
there is a Starbucks in a Target, which is across the street from another Starbucks. I don't understand how that works, but it does.
So the only disruption that will not happen in 2025, but in the long run, a disruption can happen in the data center world is so water. Water is used for cooling. That is a big resource need, and energy is another big resource need. But let's say the price of energy comes down, right? uh, then let's say then it can move quite substantially, right? Let's say solar panels become very efficient, then there may be a case made to say that, okay, these things can be located in in places that earlier it was not even possible, right?
Yeah, and in the chat here we have from Stephen OK says he's pulling for the build-a-thon being what gets us to commercial fusion, which
Right.
hey, it's great minds think alike, I guess, I think yeah, nuclear seems like the way to go here, folks. I don't know. So let's first let's shake up Gudetama. Gudetama, we beseech thee, tell us, will the data center build-a-thon go well this year? It says, leave me alone. All right. All right. Thanks for that, Gudetama. Up next, revenge of the open source. Architecture trends toward transformers versus convolutional neural networks. I think the reason I added this, or I had originally written this one down, is because has been a trend the last couple years, I think, among the bigger companies like your Teslas and your Apples and your Metas, et cetera, to keep a lot of their work around AI, be it transformers or CNNs, to themselves. They're taking the state of the art from like the papers that are out there and stuff like that, and then doing their own versions and guarding them like Gollum. They're keeping the secrets to themselves. I think as we get better and better results from these things due to advances in hardware, due to good open source implementations of stuff that you can't really tell the difference between that and the state of the art commercial one, a lot of that stuff's going to come back to the open source community. Thoughts?
I have some slides I can share to maybe ground some of this context
Yeah.
too. So our team, I just sent the request for screen share to the all
It
controlling.
has been approved.
Look at that. So our team at NeurIPS this year provided a research roundup of some of the trends that we're seeing. So basically to ground some of the context of what's going on in open source and what should we expect to see within model capability within 25. And I recognize we're tight on time, so I'll be quickish, and I can share the link to the longer form version of this talk.
Yep.
But DETRs, detection-based transformers. So generally, YOLOs, which are kind of CNN-based capabilities, have kind of hit a plateau, and this is in terms of COCO, eval versus speed. So they're getting kind of marginally better, which is awesome and helpful. And if you contrast that with DETRs, for example, so to just align where we were on the last graph, we were like here-ish. And DETRs continue to show promise, right? Like more stepwise gains and capability. And the reason for this, we think, is because DEETers are able to capitalize on a key thing that transformers are by comparison to CNNs. And what that characteristic is pre-training context, like all the pre-training context that makes its way into some of these transformers. So, for example, Define, which is the current state-of-the-art model, produces the highest quality results on Cocoa. And even more exciting, it's kind of like it's almost like DEETers are maybe where the next stepwise change is going to be in continued architecture improvement. And at Roboflow, one thing that we're particularly sensitive to is not just Cocoa performance, but also like across real world performance. So we've taken some of these models and we've benchmarked them in that context. And before I show you the real world comparison, you might say, okay, well, DEETers, they're great, or transformers are great, but they're huge and they're often slower. And so that's where we've actually seen the community publish real-time DEETer, which speeds up to roughly YOLO-ish speeds. So basically, you can be like, okay, so if transformers are increasingly able to be more accurate and they've shown promise of speed, then it follows we should expect to see a DEETer, a real-time DEETer that would capitalize on the benefits of pre-training context and the speed benefits that we've seen from real-time DEETer. And what's exciting about this is when you use pre-training, so pre-training with YOLO family models, RTM Deader, or RTM Deader, or some of these other YOLO model capabilities, and then you apply that head-to-head against, for example, LW Deader, or even Define, you have how this performs in real-world contexts. So this is, for example, with RF100, you see how well some of these models in general adapt. So we basically said, hey, at Roboflow, we're like, okay, so here's the latest, greatest state-of-the-art transformer-based detectors. Here's the latest, greatest state-of-the-art SIM and the CNN-based detectors. If we compare those head-to-head on real-world domains, which ones adapt better? And you see that adaptation happens slightly better, marginally, not uniformly across all domain types, but it appears that these models are able to use some of their prior knowledge context for new domains more richly, which is really exciting. That basically means that like you could have a model that says, I'm going to learn your context and your domain better and potentially run faster and more accurately. And so I think what this means is it's not going to be unlikely that we'll continue to see stepwise changes of the next generation of, at least for some of these task types, like some of understanding of segmentation or object localization. You'd expect to see transformers be continuing to trend in that direction. So that's a little bit here of some of the research roundup we had from NeurIPS, but I think it's a sign of things to come of what it means to have both VLMs, which are transformer-based performance, but even just applied to single task-wise where things will go.
That's interesting. And
Yeah.
on the open source question, I just want to correct one little thing. Is Meta is actually doing a great job in releasing all its model, right? And even though not all the companies have been releasing as much as they used to, right? Especially OpenAI, and even to some extent Google, they still release a lot of open source stuff, which is very useful. And Meta has
Yes.
been leading the way, right? They have been publishing like Llama 3, etc. That's really impressive stuff. There is also when people don't open source and they just write papers, even that is very useful because there is a paper, on talking heads. You take a picture and make a video out of it, like a talking head, based on text or based on audio, right? There's a paper by Microsoft called Wasa 1, and the quality is stunning, right? But they never released the model, they never released any code. But just looking at the paper, the open source community has been trying to reverse engineer it, right? And it's not still 100% that quality, but we are getting there, right? So there are a lot of open source solutions which are piecing together the puzzle. But even publishing ideas when they don't want to publish code is very useful.
I agree.
And
I
that
agree.
trend is going on. Yeah.
Yeah. Oh, great, Gudetama. Will open source benefit
Uh,
in 2025? Signs point to yes.
All right.
Let's let's quickly do our trivia giveaway and talk a bit before we go through the rest of these predictions. Thoughts, fellas?
Yeah.
Do y'all have an extra, let's say, 15 minutes?
Yeah, I do.
I'll give you 10.
Okay, yeah, 10.
Okay.
All right, let's do that. We'll do our trivia giveaway real quick here and then get back to the slides. Folks out there, if you need a reminder, one of the things we do on this show is give away something to you in the audience absolutely free. And this week, as it usually is, that thing is an OpenCV course. You can see what courses are on offer by going to opencv.org/university. There's a big promotion going on right now, so even if you don't win today, maybe get yourself a course, upskill, get a better job, get paid more at your current job, or just learn something new for the sake of it. The way this works is I'm going to ask a trivia question based on today's topic, and the first person to answer that question correctly in the Zoom chat will win the OpenCV course of their choosing. If you have won in the last couple of months, do not answer and give someone else a chance to win. We've been doing these prediction shows for a couple of years now. In what year was the first OpenCV predictions episode? What year? What year? There we go. The
Okay.
first one was Stanislaw, 2022. Congratulations, Stanislaw. Please send one email to Phil, that's me, at opencv.org with the name of the course you would like, and we will make sure that you get that in your OpenCV courses dashboard. Having said that, Joseph, do you want to take over the slides? Do you have more context, or should I just reshare my screen?
If you reshare yours, and then there's one prediction further down where there might
Okay.
be some relevant research context to share.
Easy peasy. Can you all see that?
Yeah.
Okay. So, vision models. Let's talk a bit about vision models. I think, Joseph, this one was one of yours, perhaps. So let's
Yeah.
talk a bit.
We're generally excited about vision language models. Actually, ties really well to the prior note here, where vision language models, kind of take advantage of more context to understand the world around us, right? So you could have a semantic description of the world and you can have a visual representation of the world. And training on models that understand both those things concurrently allows you to have a richer representation. So naturally, you're going to have a more accurate representation, which means a more accurate model. And so I think what's going to happen is VLMs right now are not like uniformly better at all the existing like CV tasks. But they are quite strong at having lots of out-of-the-box context. And that, for example, if you think about traditional like way of breaking down task types of classification problems are really well handled by VLMs because they have such a rich amount of context in an open form way. Like you don't have to just assign, a very rigid single class. And what does that do? Well, that creates, I think, a world where VLMs can power, like you don't have to know actually as much context about computer vision. Like you can be a software engineer and get a lot of value from vision models without needing to think about, oh, what class problem do I break this down into? How do I think about getting the data? It's like I can just start to use an API and start to get value out of understanding visual scenes. So that's one implication of like a second order effect here. I think a second is, capitalize on the value of pre-training, meaning you can kind of start at the end. Like you can use a model that understands things and kind of start to deploy it and then collect data and adapt the model. Whereas maybe 5 years ago, it was all about, let me just collect the data first and then train something and then deploy it. I think increasingly we'll be able to be in a spot where like I can start to deploy a thing and then
Yeah.
collect some data of that thing as it's running and then do some fine tuning or adaptation or multi-shot prompting of what's possible. And then maybe a third thing that I would share in the context of vision language models, when you interact with a vision language model or really any embedded knowledge of a model, you can interact with that context in a few ways. One is you can prompt it with text. Like you can say, hey, like I want to know in this image or this video, like show me all of the trucks or show me all of the people. So you provide a text prompt to get that information back. That can be a little lossy, right? Because like, did you want like utility truck or like pickup truck or semi truck or is every vehicle a truck? Um, but nonetheless, it's one way to interact with a visual understanding. You could also interact with a model with kind of like a visual prompt, which is what like Segment Anything introduced, like the idea that you can like click on one area and say, hey, this is the region that I'm interested in. And you kind of see like an expanded view and Tools like Roboflow, for example, capitalize on both these techniques, where you can prompt with a bunch of text and get a bunch of labels. You can prompt with a click and get some labels. A third area that I think is extremely under-indexed and will grow in prominence is interacting with models with visual prompts. So you provide a visual of what you're interested in, and you provide that as context for the model then to provide back feedback or recognition. So for example, instead of saying, hey, I'm interested in all trucks, you provide an example of an image of a utility truck. And then the model has like just the cutout version of that portion of the class, for example. And then the model is able to much more precisely map regions of interest and understanding to the prompt that an end user provided. So it's similar to like, clicking one part of an image, but you could even just do like visual prompting even more naively and get really higher quality results. And so one way that we've experimented and introduced this directly into some of the platform that we've been building is something called box prompting, where you basically like you're interacting with a model that kind of acts more like a co-pilot. When you start to say, hey, these are the regions that I care about, the model is being like live retrained in real time and is then finding additional areas that you care about in an image. And while that's in pursuit maybe of data preparation, you can think about that being in pursuit of actually of production itself. Like I have this scene, correct the model a slight bit, and now I have this better model that I can continue to use. So in the context of VLMs, I think each of those areas are really important. And then last thing I think is what I shared at the very top is these things are severely under benchmarked. So I'm making a lot of claims here about their performance and their capability and where they're going to be better and where they're going to be worse. That's like we as a community have work to do to be able to compare the performance of one VLM to another. And this is always kind of like a tricky game because the second you introduce a benchmark, people start building for the benchmark, which suddenly like doesn't work as well in like the domain context. So it does end up being this maybe cat and mouse to some degree. But one of the reasons that you remember perhaps that Coco got so popular was they held out the test set altogether. And so people couldn't just train to perform well on the holdout test. So I could see something existing similar for steering and engaging and enabling VLMs to be held to ever improving standards. So those are some of the trends that I think are going to be really exciting in the context of vision language models within 2025.
That's awesome. Yeah.
Yeah.
I'll just add a couple of lines. You know, large language models provide something that vision models used to lack prior to vision language models. Two things actually. The first is world knowledge, right? So when these large language models are trained on all the text from the internet everywhere, right? So they understand the world, right? They have knowledge about the world that when you train a computer vision model, usually a small, not a foundation model, but a regular computer vision model like YOLO, you basically tell it what you want, right? Let's say an object detection model, you have to tell it, okay, these are the things that I want to detect it in this image. It doesn't have any context of the world outside that reference frame. What language models give you is context, right, of the entire world, right? For example, let's say you have a shelf, right, of different objects, grocery store. You have a shelf in a grocery store, and you want to identify all the different products in that shelf, right? Now, if you were to train a vision model for that, there are 100,000 SKUs in a grocery store. It's impractical. You simply cannot do it. On the other hand, if you actually if you did an object detector, which is class agnostic, and extracted all the text from it, and then you basically used the large language model to identify these. So let's say you detected a shampoo bottle, extracted all the text from the shampoo bottle, and asked a ChatGPT that, oh, what object is it? It will tell you that this is this brand of shampoo because it has world knowledge, right? So vision language model basically help us combine those aspects of it. And the other one is the language understanding, right? The vision models did not have language understanding, how to interpret language. So now a lot of applications where vision is involved, but you're talking to the application through a chatbot kind of application that opens up. So I see a huge number of applications of vision language models in 2025. but there is also this other two-step process where you use vision plus a large language model. That also can also be, there are many applications where such things will also be used.
Well said. Let's keep a rolling here. Agentic, agentic AI, agentic AI. So this is, taking the concept of these AI agents have gotten pretty popular. People, I think this was one of the first big use cases that was tried for this. Really, was like sort of the chatbots were an early version of this. Um, agentic AI. Thoughts on this, Satya?
Well, I put it there just because there is a lot of noise about it. I hate the term. I hate the uh, concept itself because this is one of those hype things I feel that people are going to fall on their face while trying to do this. Because so what is agentic AI? First of all, it is you tell an AI to do, you give it a task, right? And say that use whatever resources you need to use other AI models, etc., and give me a solution, right? And that has become very popular. That concept has become very popular, and people say that okay, you can always do toy problems, which actually get solved, but I think we are very far away from something useful, right? Where you say that oh, go buy me something on Amazon, right? Um, you know, uh, Based on such criteria. And there is a huge trust factor problem that people have. But also, I think the hype behind this agentic AI is more than what it is able to deliver. So last
It
year,
honestly
2024.
seems like one of those things this is, to me, it seems like mostly driven by the excitement at the venture capital class that they can hire fewer people. Like, there's nothing that like the Andreessen Horowitzes of the world hate more than paying support people. They hate paying like support leads. They want it to be a robot. And so they're going to keep investing insane amounts of money in this stuff to make that happen because they don't like dealing with people. Thoughts, Joseph?
I think there's places where agents are going to be useful, and then there's places where they're not going to be useful within 2025. So I think agents over the long run will be useful. I think agents in the short run, um, will run into a lot of blockers. I think coding agents are already probably in a spot where they can assist quite a bit. Now, this kind of gets to like, what do you fully consider something to be agent versus a model? And a definition that I've seen that I kind of like is like it's a model plus planning plus memory plus tool use and then like some ongoing people will say like a while loop, but like ongoing compute that's taking place. So you have like, or maybe another way to think about this is like it's a you provide a task-based outcome and a model and a set of tools and planning and program gets executed to accomplish that task-based outcome. I think
Yeah,
there will be real and valuable agents that get deployed in 2025. I also think that we will have a long way to go before they can be, it's basically a question of like what level of abstraction of a task can you provide to an agent where it's going to be successful.
right.
And in the context of vision, I could see us being in a position where you could prompt and say, tell me all or count all the people that are in this video. And then an agent goes and plans, okay, great. I need an object detection model for people. I need a way to maintain the state and track and keep track of how many people I saw. I need a database to store that in, or maybe a place to post that data. And I'm going to run through this video until I find all of those examples. And I could see like us being able to build and deploy that today. And so by that definition, I think that that's a valuable agent that gets built. One of the things that like we've been working on with the inference open source product is the ability to orchestrate multiple models together. And pretty soon, and those all get represented as JSON. And it's an open source project, so you can kind of change and edit and contort how you want. I think we're not that far off of being able to like train an LLM to take like an objective and then output the JSON. And that JSON is the series of blocks that one would want to run. Like a block here, meaning like I want to do a model, I want to do some counts, I want to do some aggregation. And so I'm pretty
Sort
excited
of
about
node
that
node
category.
outputs, more or less.
Yeah,
Yeah, like I'm excited about that category of agents. But again, like agents that are like it's almost like um when you think about um, army of interns as the definition of AI, it's like there's a lot of like army of intern, maybe well-pointed, specific, narrow work to gain context into a domain that I think we'll see within 25. But um, I
Yeah.
I'm not sure, what level of abstraction they'll get to within this year
So
alone. If the hype is greater than the capability, hard to say.
so I actually think so. There are a lot of good use cases, and many of those things will show up in 2025. I just feel that the hype, because I went to conferences where all they're talking about is agentic AI, and it feels to me that the hype and what people expect. So there is the actual thing, and when it gets translated to the media, right, they have a completely different notion of what things can be done. I actually feel that some company is going to run out of, go bankrupt because one of their agents consumed all the resources or something happened.
Yeah, sure. That's totally
That's a fun
possible.
prediction. Satya predicts that one company will burn through all of their money because an agent went rogue. I love that.
Well, I think
Let's
I think
revisit that.
yeah, no, I think we're that one's definitely getting brought up in the 2026 predictions, and probably we will realize that we undershot it and it's like a half a dozen companies or something. But let's continue. Number five, Generative AI 2.0, the rise of video generation using prompts, talking heads, and synthetic data generation. 2024, we saw a lot of improvements in this tech. Um, I think, yeah, it's getting to the point where it's kind of scary. It's still everything still does have that sort of uncanny sheen on it, but very short videos are pretty damn convincing, and I think of all the stuff in AI and computer vision, this is what we're going to see the most of in the news this year, I think, is people being scammed or tricked or whatnot by pretty dang convincing generative AI stuff. Thoughts, Joseph? I know you got to bounce soon.
Yeah, I do have to jump here in a minute. If I had to classify what Gen AI 2.0 is, I think that I'd put the category actually of like foundation world models broadly in that category. I'd
Yeah,
put the text to video generations that we said are going to continue to progress in this category. I really think a lot about diffusion based use cases, and then maybe it's, I don't know, it's kind of like a semantics debate if you place this here, but benefiting from pre-trainings for VLMs is technically a form of generative AI, and I think
yeah,
there's a lot of room to run um, there. So those are like capabilities that I don't see a ton of scaling laws blocking fast progress in each of those domains.
yeah. I was actually surprised by all the progress that was made in video generation in 2024, and now I'm very optimistic about the future, 2025. The length of the videos would substantially increase. All the work that is being done for converting a single photo into a talking head or a scene generation. So
Yeah.
those lengths of videos, etc., will go up, and the quality is uh, once the physics works right. And I don't know whether it is possible to get the physics right by just training on more data. I don't think it will, right? And sometimes it's not even desirable, right? So when you say that a car is make a car drive on water, right? There, uh, it's funny because the LLM understands that you actually don't want it to sink, right? It's actually driving on water. The physics would say that it would sink, right? But that physics engine, when it works with Gen AI, I don't know whether it would be a separate thing that will need to be trained or additional data will be sufficient. But that is something that I'm very excited about in 2025.
Well said, both. I think we got one more video as a modality. As well as depth localization. I know this is something, Joseph, you're super excited about, and at OpenCV we've been talking about this a lot, especially like camera localization and things like that. So, Joseph, we'll go with you first here, and you can feel free to drop off when you're done talking.
Awesome. Yeah, so the video as a modality, what I'm referring to is SAM2 introduced the concept of training attention on not just images, but also spatial reasoning and temporal reasoning. And this makes a lot of sense because videos, for the longest time, vision models have treated them as an independent sequence of frames that each model is going to run on. In reality, video frames, of course, have relation to the frame before it. For example, if I drop a ball, that ball's position is non-arbitrary. Like if it's falling and you knew it was here in one frame, the fact that it's here in the next frame and here in the next frame is actually a sequence that we can model and understand and therefore predict, which allows us to create a better sense of object permanence as well as scene understanding and localization, and lots of downstream tasks can follow from that. One of the big unlocks has been the ability to scale up in parallel the training for those architectures. And I think that we will get increasing numbers of so-called video foundation models, and I would bet that SAM3 is like fully like video presumptive. And maybe it has like an image mode, if you will. It's like you assume that you're working with a video and maybe there's an image. Because if you think about it, like modeling a vision problem where an image is a unique example as a video is like actually perhaps a more elegant way than a video is a unique form of a sequence of images. And so I think this temporal-based attention dimension has a lot of room to run, and we're just scratching the surface of it in the SAM2 research. The same thing I think applies to other modalities like depth and spatial reconstruction, right? So if you train with the sense of depth at the same time, and that's why you've seen like depth anything, for example, like that was a model that introduced the concept of, oh, we can actually infer a sense of depth from even just a two-dimensional um, estimation. And I think that in 25, those trends are going to explode. Like the quality and capability of models with video understanding. And similarly, I linked this in the chat, but the research recap that we did at NeurIPS this last year included a section on what we expect within SAM2 and potentially future versions of SAM for the purposes of maintaining spatial temporal context. So I'm extremely excited about video as a modality, both yes for generation, but also for understanding and modeling time as a part of models just as much as other dimensions.
Yeah, I completely agree with you. That's a big shift that is happening. And in 2025, I think using that temporal dimension, in various architectures, that is going to be pretty big, right? And not only that, right? There is video, and you can also think about a collection of frames, as in for 3D generation, Gaussian splats and others. Those things are going to become very popular and be actually usable, right? So there've been, a lot of research has been going on for a very long time in these areas, but I think some explosive growth is likely to happen in 2025.
Yes, I think you're both right on this one. I think this is one of our we're all pretty close to this one, I think, and so also kind of hyped about it ourselves, and so it'll be interesting to see how this one shakes out in our 2026 review. Having said that, though, I think we're basically done here, folks. We've got some questions. We got some
There's a
questions from
question
the
about
chat.
glasses, which
Yeah.
I think that's a very interesting modality, right? These AI glasses, they don't, because they are, at least, I think Meta is pricing it very smartly, in the sense that they're not making any money on it. So
Yeah.
these glasses are $200 glasses, and you can buy a frame for the same amount, right?
Yeah,
That's
if anybody, if it honestly, if it was anybody but Meta making the Ray-Ban glasses, I would totally have a pair. Like just because they're interesting, they look pretty good. Like the Snap specs, the Snap AR glasses, like you're very obviously wearing a piece of tech on your face. They're
right.
cool, and I really like what they're doing, but
Yeah,
they're not the Meta. Ray-Bans are just meant to look like regular sunglasses, and
right.
that's pretty cool. If it was any other company but Meta, I'd probably check them out.
So I know some of my friends have bought it. The price is very reasonable, and the quality of videos that you get out of it is very reasonable. Um, I think they will continue to be very, very important. Joseph?
I'm excited about it. I mean, Roboflow, a lot of folks know, started with building AR applications,
Uh-huh.
like a magic Sudoku solver. And good thing that we didn't wait for AR we'd still be waiting.
Right.
That said, there's a lot of earnestness and excitement for new compute modalities that actually bring like vision is the back end and AR is the front end. Like vision does the understanding, the processing, and the logic, and AR does the visual representation of interacting with the scene. And yeah, a form factor has been missing to make it be like less dorky. And I've had the chance to try out like Meta Ray-Bans glasses too, and they're impressively good. Like it's in the background. The way they do audio to you and only you without like earbuds in your ears is also quite neat. It's also cool to like have images captured of memories of your first view perspective. Like I think
The POV, yeah.
yeah, the POV, I think that's going to be a whole like new set of data to like understand and train on. Speaking of like think about a foundation model that's trained on like first person
Yep.
view. That's going to
Yep.
be requisite. That's going to be necessary. I would put money that we will get probably from Meta a first person view model that understands things because otherwise, right now all of our images are captured from like
Yep.
posed positions or maybe sometimes like fixed security cameras, but first person view is still underrepresented, I would call, in
Yep.
like the context of what stuff looks like from that uh, perspective, looking up and seeing things or down. And
Right.
so I bet we'll get a foundation model for first person view actually is
Yeah,
going to
they have Meta has Ego 4D dataset, which is basically from that view.
And again, this is basically what powers the Squid device in the 1995 science fiction thriller Strange Days, starring Ralph Fiennes, Angela Bassett, and Juliette Lewis. So go check that out because it's becoming more and more realistic every day. Yeah, it's this little device that records not just the. So another thing to think about here, what happens when you're not just recording the visual aspect or just the audio and video, but you're also say like taking the pulse rate, like you're taking all of these other sensory measurements of a person and then say maybe able to induce those same sensations in the viewer later on. That is when things get really spooky. Um, but having said that, I mean, we've answered almost all of the questions somehow during the thing here. There's one more here, which is about, yeah. So people are really interested in the glasses apparently over on over on LinkedIn. Do you guys have any other examples of some? Because the two big ones obviously are Snap and Meta. Are there any other cool ones out there? We were just, CES was just happened. I'm sure there were a few on display, but I haven't had a chance to look at them yet.
No, I know one uncool one that died.
Well, yeah, I mean,
Google,
there's,
Google Lens cannot.
yeah. Yeah, that Robert Scoble
Yeah.
photo really tanked a lot of. They should have gotten like The Rock or somebody to take the shower photo, and it would have been gangbusters, like Timothy Chalamet or some shit. Anyway, I think we're gonna call it a day, folks. Satya, you wanna take us home?
Yeah, first of all, Joseph, thank you so much for this show. It is amazing to talk to you. Whenever I talk to you, I get enlightened. So thanks for being a silver member and being part of many of our shows.
Thanks for having me.
Thanks. And thanks, Phil, for organizing this show. And thanks our audience for showing up almost every week for these webinars. We enjoy it a lot, and this is our chance to connect with the community. Thank you all.
Yeah, absolutely. And so before we go here, folks, I just want to say, as I always do, take care of yourselves out there. Take care of somebody else if you can. Have a great day wherever you may be. We're going to wish some happy trails to, I just saw this today, the one of my favorite ball players, the late now great Bob Uecker, probably, not even probably, without question, the funniest baseball commentator in history. Please go look up some of his Miller Lite commercials over the years. Just one of the great ambassadors for the greatest game that's ever been devised. So happy trails, Bob. He's cracking jokes with the greats now. Take care, folks. We'll see you next week. Adios.